Today I want to quickly go through with you the concepts related to orthographic projection. Now you may have heard orthographic projection, and under orthographic projection you may have heard first angle or third angle orthographic projection. So I just want to explore with you today these two types of projection and make sure that we are crystal clear with regards what they mean, what rules should be applied for each one, so that there's clarity with regards producing any drawing in the future. So looking at this page, there's a number of confusing things here, and I will explain them as we go through. I want you to imagine that the representation on the left, right here, is a vertical screen and a horizontal screen joined together. So that's where you get this L shape at the front here. This is basically a pictorial representation of a vertical and horizontal screen. Now please try your best to ignore the ones on the other sides of the page. We'll get to them as we go along. This line going across here, this green line, let's say that this is a hinge, which means that I can unfold or open these two screens to set them down flat onto a surface, a sheet of drawing paper or something like that. So what is represented at the bottom is these two screens folded open to sit flat on the sheet of paper. Now let's call the vertical line and everything related to that line the vertical screen, and let's call the horizontal line and everything related to that line the horizontal screen, or the vertical plane and the horizontal plane. So when we have done the unfolding, the vertical plane here is this portion at the bottom, and the horizontal plane or the horizontal screen is this portion at the top. We will refer to them a little bit later. Now I want you to imagine that we took a cube and we placed that cube onto the screens or in the space so that they can be projected onto the screens. So we're only focusing on the one on the right, even though you see things happening on the left as well. So this cube that's represented here can be viewed, because now we say that these screens are transparent, which means that you can look through from the back and see what's happening, or look through from the top and see what's happening. So when we look at this drawing as it is represented here, if we were to pull this drawing onto the screens, then we would see the shaded portion that I'm going to put in now. We would see the shaded portion here in red ending up on the vertical screen inside here. So you would note that that red portion now is represented on the vertical screen at the bottom. Remember that that ended up being at the bottom in this situation, right? And then if we look at the top face, which should be on the horizontal screen up top here, if you're looking through this transparent screen, then this would represent what you're seeing through that horizontal screen in that horizontal plane down here. Now this, if we're labeling, as we will talk about labeling later, this on your drawing paper in the vertical screen would be called a front view, while this in the horizontal plane on your drawing paper would be called the plan. Now on the other side, where the screens are in a slightly different orientation, where the horizontal plane now rests at the bottom. Vertical screen is still vertical, hinge still in place. What we will imagine here is that these screens are solid. So they're not transparent, they're opaque, which means that you can't look through. You have to cast the image exactly onto the screen. So in this situation, on the vertical plane, you would see whatever will be projected in here. And if you look down here, the vertical plane, because you're hinging and folding it down, the vertical plane would now be at the top in this situation, while the horizontal plane, because it hinges down, will now fall at the bottom. So this representation, though it shows the same information as the one on the right side, the orientation of the views are different, and it's important for you to remember that. So the one that is on the right is called third angle projection. The one that is on the left is called first angle projection. Now, we remember what's happening with these by saying that in third angle projection, because we have the transparent screens, the views stay exactly where you look at them from. So you look straight on for the front, that view stays in position. You look from the top, so that view, which is the plan, is drawn on top of the front view. In first angle projection, opposites start to play. So the front view will stay on the vertical plane where you look at it from, but when you're looking from the top, you're pushing it down onto the horizontal plane, then opposite happens. So you look at it from the top, you draw it on the bottom. Now, you can have another view because you realize that there's a third face represented on this block. So, bearing that in mind, if for some reason you needed to represent then the other view, which will be referred to as an end view, looking from this left side here on the first angle projection representation, then you could imagine that another plane existed. So on your drawing space, you could imagine then that we created another plane here, so that the image from this face would end up at the back here. You could imagine as well that this face were hinged too. So if we make that little change now, then you could imagine that we made this a hinge here right now. So if we represent that on the views at the bottom, then we'd have, and I'm making it small so that we can fit all that we need to fit. We'd have then another view represented in this space, still in the vertical plane, but that's the view now looking from the side. So in this instance, you're looking from the side, from the left side, but represented on the drawing page, it is represented on the right side of your front view. So please remember that, because that is very important. That opposites tend to play out on this drawing, which is called first angle projection. Now, on the other drawing, remember we have transparent faces. So if we were representing an extra face on this one, then it would fit outside here, something like that. It would fit out here, something like that. And then the view would be looked at from the outside, and this view would now be represented on the left side of the front view. And represented on the left side of the front view, we could then pull that plane in like this, and it would be on this face that we would be representing the extra view, which is referred to as an end view. So these two layouts give you a good representation of what should be happening with regards orthographic projection, whether it is third angle projection as is represented on the right, or whether it is first angle projection which is represented on the left. Now, I also want to explore with you how a line is projected and what happens with the line, because this will lead us into the next topic that we will also be exploring. So we will just try to put our focus as best we can solely on this one, and bear in mind that we are representing here a line. So if you took your pencil and you held that pencil up in front of you, then what you would be seeing for that pencil, if that pencil were a line, would be this line that I'm represented here as your front view, this blue line. The point, or the X I'm representing at the top, would be the plan, because the plan of that line would basically be a dot. So I've represented that up here. Now, if we're doing orthographic projection, then we would have a line coming at 45 degrees that would allow us to pull that dot to 45 and then bring it down the page. We would also be able to carry the height of the line in the front view, and that would give us this line in the end view in this instance. So we could also have another line on the other side for the end view. But this is what we would be representing here as three views of the line, three views of your pencil in this instance. This front view tells you the actual height of the line, and this end view tells you the actual height of the line, because your viewing point is always at right angles to these lines. Now, if you look at the one at the bottom, imagine that you have changed the pencil now and that you have placed the pencil at an angle. So when you project to give you the plan, you no longer have a dot. You will have a short line representing the plan, but the length of that line is not the actual length of the line of the pencil that you're looking at, or the line that you're looking at. But you go through the process of projecting again. So you locate the highest point, you get your 45, and you project the line across and down for the end view, and then you project the height of the line across as well. Now, this height for your end view is not the actual length of the line either, because the line is on an angle, so then the views become distorted. The actual height can only be seen by looking at that line in the front view, or in the vertical plane in this instance, right? And this line will be measured going down here, because you're still in a position where you'd be looking at this line at 90 degrees to the line, or at 90 degrees to the pencil, if you're still holding that pencil up in front of you. So there will be instances where neither of these lines fall in the vertical or horizontal plane, and you will need to work out what the actual length of the line will be. That is the next topic that we will explore. So I just wanted to give you this little introduction so that that would help you to understand a little bit better when we come to explore that topic, which will be called true lengths. But just remember the basic principles of orthographic projection, how you arrive at a drawing in third angle projection, or how you may arrive at a drawing in first angle projection, as well as how you may project a line through a drawing to represent three views of that line. If you think then that a drawing is made up of a series of lines, it will make sense with regards how then a drawing can be projected through the principal planes of projection to allow you to have three views of the drawing of the object as well. This ends the lesson for this topic. I hope that you understand. Hopefully this preps you for us moving to the topic of true lengths. Thank you for your time, and I look forward to presenting to you again.